All right, thanks a lot for the nice introduction. So,
thank you.
I guess we can skip the introduction of ourselves then. Gustav will introduce himself a bit more later. I will start with a couple of slides about Brainamics, my startup, and what we're doing. And then later on we will show you a case study of how our technology is applied in practice by Pixel Federation. So what can you expect as a takeaway from this talk? On the one hand, we will explain first how the brain works, on a very high level, of course, but that you get a baseline understanding of what this all actually is about. Also demonstrate the importance for user research in general, why user research is important in games and the core problems that exist at the moment there, and how neurotechnology and AI can overcome those problems. I'll introduce a bit more about Brainamics. So what we actually developed. We developed a software that consists of deep learning networks that translate raw brain activity into emotions on a second-by-second basis. So how do we do that? We use those devices that you can see here. They are called EEG, so electroencephalograph. And what they essentially do is they measure the electrical activity in the human brain. So whenever you think about something or whenever you have certain emotions, there's different neurotransmitters that get emitted in your brain. For example, dopamine, or many more. But I will explain a bit more about it later. And they cause an electrical activity, which is then measured by those sensors. So those sensors are electrodes, and they essentially just measure the electrical potential in the brain. And then when our technology, so our software comes into place, once we have this EEG signal, we translate it through the software into emotions. And that's then the core or the basis of that we use to make any analysis about the games. And when we use this technology during the game development process is like really from the very beginning till the post-release. So we use this for most of the time for playtesting. So when you have a very raw prototype and you want to first see how is the UI, UX perceived, how is the usability, we can already use that. Then throughout the production to fine-tune the user experience, fine-tune the emotional experience, that's when you can use it as well. And even post-release to fine-tune new features and check if updates are actually perceived well by your target audience or not. And the case study that we brought for you today is it's like an experiment that Gustav and I did recently, and that's even for the very, very early stage. So before a single line of code is written, so when you're still in the concept phase and ideation phase for a game, we checked if the technology can also be useful there. But more about that later. So now a bit more background on how the brain actually works. So maybe some of you already know a little bit about the neurophysiology and so on, but in general the human brain consists of tens of millions of neurons, which each are connected by synapses. And when we have certain emotions or we make certain decisions, there's the neurotransmitters that get emitted in the brain. And to illustrate that for you, we give the example of dopamine. So this part here, the highlighted part, is the prefrontal cortex of the human brain, and that's where dopamine or serotonin get emitted. So when you're like really happy about something because you just won the lottery, there's a lot of dopamine that gets emitted in your brain, and this will always be in this part. And what happens next is that the neurotransmitter gets received by the synapses that connect your neurons. And once those synapses receive the neurotransmitter, they activate the neuron. And as we might still know from physics classes, neurons that get activated cause an electrical potential. And that's then what we can measure. And from neurophysiology, we know exactly in which part of the brain which neurotransmitter gets emitted, and thereby also which neurotransmitter is responsible for which type of emotion. And that's on a very high level how it works. But I don't want to bore you for too long with this neuroscience. So let's jump into user research and into games. So typically when you do the user research in games, you have a game, there's some stimuli, it induces feelings, it causes decisions to be made, and that all happens, that all happens in the brain. And then what you try to do in user research is through surveys or through interviews, you try to understand how those feelings occur. Like what feelings do the players have, why do they have it? And here we have the first problem, which is the encryption. So the player that plays the game needs to encrypt his feelings and his decisions in the form of the survey. And then, as a user researcher or game designer, you of course try to decrypt again what the gamer encrypted. And then what you try to get in the end is like these feelings that were caused in the beginning. And this is like two subjectivity layers that you basically have that are prone to error. And therefore you cannot really rely on what you get out in the end. And there, the emotion extraction that we provide through our software is kind of solving this problem because we directly take it objectively and accurately from the human brain. And to give you an example of how it looks in practice, so this is a very simplified example how we classify the emotions. So you can see here in the top right corner a two-dimensional coordinate system. And on the one axis you can see, so on the ordinate you see the value that we call arousal, or you can also call it activity. And it's basically a measure for how strongly your nervous system is activated. So if your nervous system is very strongly activated, then you perceive emotions quite intensely. So then you're up here, you're like really active. Otherwise, you're rather passive. And the second dimension that we have is the valence. You can also call it positivity. And this is a measure for the dopamine and serotonin concentration in your brain. So the higher this is, the more positive you are, otherwise rather negative. And since we do this on a second-by-second basis, we can also visualize that in time. So you can see here on the time axis, the blue line is for the activity value, so for the arousal, and the orange line is for the positivity value, so for the valence. So let's play the tape and see what's happening here. The bubble that is moving is eye tracking. So in this example, the player needed to cross from one building to the next building. And before that, the player fell down twice, which is why we had here this fluctuation in the positivity before. But now the player will be finally successful. So you can see how his positivity peaks at a very high value. You can also see here he's really happy and really positive that he finally made it. And the next challenge for him is now to further climb up the building. So he's starting to look around and trying to understand what to do next. But as we can see, he's kind of lost, doesn't know what to do, he starts failing. And that's when we also observe that his positivity value drops pretty rapidly. And at the same time, his activity is increasing. So we see that he goes all the way from being really happy about his achievement to being quite anxious and frustrated because he's still failing and doesn't understand what to do, until he realizes here with the eye tracking we can see nicely that he notices the hint which tells him what to do, and then in the end it was super easy. And we can see his positivity will recover now again. So this is like a very simplified and short example, but just to show you what the game designers then can see. And also what's worth mentioning here, so our internal brain mapping is 12-dimensional, so it's much more complex than this framework here. It's just to be more intuitive and kind of make it easy to understand, we chose this visualization. And this already has like really revolutionizing implications for game designers because you can objectively truly understand how players perceive the game on a second-by-second basis, which is really amazing. Another example is when we map the emotions not in time but in space. So we have the map of a game, it's from Divinity, maybe some of you played the game, and then we color code, again on the same two-dimensional representation, the emotions, and then you can see on the map in which part of the game, in which location the players had which kind of emotion. So this is just another visualization to give you a glimpse of analysis that can be done. All right, and then we basically started with this kind of stuff 1 year ago with the business part of it. Like before that, we had a couple of years of research in the university. And then pretty early, I think one of our very first customers was Pixel Federation, so very open-minded, forward-thinking and innovative company.
Yes, please.
And yeah, we did a lot of projects already together, and today is also the case study with Pixel Federation, so I would hand over to Rockstar producer Gustav.
Well, thank you very much. So, wow, right? First of all, wow. How can he leave me here standing for, 10 minutes without saying one word? But also, wow, the technology is amazing, right? So this is why I did it, like we did this presentation, so that you can see what was my feelings when I first encountered Philipp's tool. It was like, okay, we can do something about it. And why did we things with it? I believe that it was predetermined by my past a little bit, and also by my current job. So to give a quick introduction, what I do and what I did before is that before joining Pixel Federation, I was 7 years in finance, and this actually quite nicely tracks both Swissy and Euro exchange rate, but also my emotional state doing finance because it was, it was going down, to say the least. But then I came to the industry where there is a lot of creativity, and I get to deal with this amazing concept. I get to be part of killing them too, which is sad part of it. But I guess that's life. But what I like most about it, and when I compare these two industries, what I like most about gaming is that you can actually influence your success in the market, and you can influence it heavily. Like, I know that you can do it also in finances to a certain extent, but here you have direct impact. You can do plenty of things to fix it. So that's why I like it so much. All right, this brings me to the next slide. Where I'm from, right? So my current position is R&D producer at Pixel Federation. I don't believe that I really need to introduce Pixel Federation as a company, but if I would have to, I would probably tell you to play 2 of our biggest games. Train Station 2 is currently our flagship. So we do Tycoons, and in other type of games we do our puzzles. So Puzzle Adventure not being our biggest game, it's Rising Star, so watch out for that one. And Pixel Federation is a Slovak development studio, which is pretty innovative, as you will see in upcoming slides. So, but that you didn't come here to listen about me, and probably neither about Philipp, I guess. You came to learn something, and maybe to learn what we did together. How could we deploy this even in a very early stage? So first, I will start with the whole concept, how we create games, right? So, this you know, I'm pretty sure. So you probably start with a concept, then you go into prototyping, then you go into pre-production, you do some soft launches, and ideally, if everything is correct, you go to production where you then global launch it with great AVE and all that, and hopefully there's going to be major success for that. Why this triangle? Actually, it doesn't display it correctly, but it displays the amount of effort, of money, of time you put into that. So in the production, you will spend much more time than you spend in a conceptual phase. But also, once you do mistakes in a conceptual phase, you take it over throughout. And if you don't see that overall conceptual error could become millions of money, that actually happens to us as we're speaking. And that it will be happening to us for upcoming future. But what we did, and what probably also my finance background forced me to do, was to try to minimize it where actually it's not that hard to minimize it. So that's a conceptual phase. And that's the phase we'll be speaking about and throughout the whole presentation. So, conceptual phase, right? So this is what would be not ideal situation for your project owner to be or the game designer to be. Like, this is blank paper, give us a game. Like, yeah, it's probably a dream for somebody who never did anything, but if you do this for a game designer, your suicidal rate at company will be like really surging. So what we did, what we tried to do, we tried to help them with some limitations. We tried to help them with some boundaries so they don't have to figure out all that they do. At Pixel Federation, we do it in a way which is probably similar to other studios, but let's go through that a little bit. So first, we actually know who are we good with. We know what kind of people we can make good games for. We also obviously do some research on what is the market size of it. You have plenty of tools to do that. So we start with that. We know that, for example, we want to make games for this particular audience, probably this genre, because we did it before. And so we establish that. And then we go to talk to those guys. We go to talk to those guys. We don't do anything. Not a line of code. Now the picture was done. Not anything, right? So people are leaving. No. So we just ask them, like, what do they like? So we ask them directly, like, what kind of game would you like to have? We ask them about mechanics. We ask them about topics. We ask them about themes. We ask them pretty much anything. And then we kind of course, process that one and do something with that, meaning that we will put some like flavor on it. So we know what they want, but now we need to compare what we can do, what we want to do. Obviously, we don't want to do games which we don't want to play or don't want to create. So that we do in our very special workshop, which I'm not going to be talking about, but maybe we can talk about it in the evening. And based on that, we create concepts. We create visuals. And those visuals usually take form of a commercial or an ad, and we throw it at the market. We just create 5, 6, whatever videos, and we throw it in the market, and we want to see like how people react to that. We also, if they like it, so they click on it, then we have them answer some questions. So at this moment, usually we know this couple of things. We know for whom we want to create the next game. We know what they say they want. We know how they click on it, which is like marketability, if we will be able to sell it further on. And we know a lot of other claim data. We ask them about what kind of show they watch in a TV. You ask them plenty of questions. And so this is, I believe this process is quite okay, and it's already helping to minimize that conceptual error, which is going to be a recurring topic. We will be coming back to that already. But we constantly think, as Philipp dubbed us as a very innovative company, we like to believe that we are. We try to make it better and better every day. So, and based on this, we obviously do some specifics of it, and we do decision if we are going to write line of codes and if we're going to prototypize that and all that. So this is how we roll, right? And yeah, but to improve this particular process, we partnered up with Philipp and Brainamics, obviously. And obviously this was done not only within our R&D department, because we have dedicated department for helping with user tests. So with help of our great UX team, we conducted this test.
All right, yeah. So the test that we did now specifically for the concept phase that Gustav described was with 7 participants from the target group. And we exposed them to 7 creatives. So those like ad-like clips that Gustav described. So 30-second clips where the core mechanic and the core theme of the new idea, of the new concept, was demonstrated. So kind of like an advertisement clip that we all see while we play mobile games. And after each clip, they had to rate it. So again, survey basically, subjective feedback. And then after the 7 clips, they had like a 20-minute survey, something like that, to fill out, right? So this was not super interesting, but still interesting. But the core value was really in the emotions that we extracted while they saw those 30-second videos and the comparison between the emotions that each of those videos induced. And the nice thing about it is that Gustav, in parallel, while we did the testing with the people in the lab, run a market test. So on Facebook ads, I think you got spend a couple of thousand euros to get some feedback from the real market. So people saw the advertisement of this 30-second video clip, and some clicked on it, and we could measure the click-through rate and the CPM and this kind of stuff.
So maybe to sum, what we had ultimately was that we had the market reaction to the video. We had the surveys when we asked hundreds of people how they feel about those videos, which one would they prefer, and we could compare it with how they felt about that. So in an ideal situation, you would have like all 3 showing the same direction.
Yeah. Let's see if it was the case.
Yeah, let's see.
And yeah, basically after we had this data collection, we ran it through our software, and then what we got out looks kind of like this. We'll explain it in a bit more detail later. But yeah, this was basically the test setup. What needs to be mentioned about the methodologies, so some disclaimer, since it was only 7 participants, it is a very, we cannot make any statistical proof or statistical conclusions for bigger populations. So it's purely a qualitative analysis that we did, but it's still, we had really interesting findings. And what comes next is basically the specification of who we tested with. So
yeah, as mentioned before, we know who we want to make games for. So, and in our case, doing games which are not hyper casual, we need people to be a little bit patient, at least a little bit more than the young generation. So we go for people older than 30 years old. Then we obviously do this kind of game. So it was kind of natural that we wanted players to be playing them too. We had a couple of specific teams we wanted our players to be acquainted with, and we sort of don't want to maybe give you the exact information on that because this concept is still alive. And we wanted to make it a little bit more secretive. But the thing is that you can determine that. And also we wanted the whole distribution, right? We wanted also payers, which we care about the most, obviously, but also just to see how non-payers are reacting to that. So this was the description. This is what we wanted. And yeah, well, we are using AI to get these results, and we kind of thought, or I thought, it's appropriate to use AI tool to show how would he describe such a, or well, what kind of picture would he, by he I mean Midjourney, do the personalization of our players. So this is what came up out of that. So these are our players, I guess.
Right. All right, so now we actually can dive into the main findings that we had from this study. So the first finding is that the best creatives, and by creatives again we mean just like 30-second clips, right, are the ones that start with a strong excitement burst. So within the first 10 seconds, you need to have a very high arousal and very high valence. What comes afterwards was actually not too important. Like the last 20 seconds was like secondary in terms of the overall success of this clip. So it really comes down to starting with a big boom. So that's what we saw in the data, both in the market data and in the EEG data that we extracted.
And that's kind of interesting to me because it's natural that it is like that on the market, right? Because you always, like on your Facebook, if you're scrolling down, you just give it like a couple of seconds, and if you are not interested, you are just not interested. But what is kind of striking for me, at least it was that I seen that we forced those people to watch those 30 seconds of video, and still the beginning was determining if they will be ranking it nicely or not, which to me was kind of surprising.
Yeah. And especially not only the ranking, but also this really translated into low CPM and into high CTR. So CTR is click-through rate. So that means that they saw the ad, clicked on it, and then what came afterwards, the survey and some more stuff. So they were really interested in this concept. And the ones that had this huge excitement burst with the emotions in the beginning were the ones that were more likely to click through a lot.
Yeah, and this is where I would like to stop for a while, because we are not going only for for the winners, right? Like that's natural that you want to find like this is the concept we should do. But when you really think about that conceptual error I mentioned, first of all, you kind of don't want to spend your time and money on something you don't want to do. And this was actually, to me, more valuable part of that was because the winners are something you will need to work with, but you just want to get rid of things which should go to the basket immediately. And we had a couple of those. So like we had 7 concepts, and 2 of them, they were really ready to go to the basket. Like we don't want to spend any time on that. I'm not going to spend any time on that either on this in the situation. So I believe that that's actually quite of an added value there too.
Yeah. Yeah, basically, so we saw then which creatives, which concepts are strong, both in the beginning with the high excitement and also with the market data. But what was then super interesting was the second finding, which was about something that market data didn't reveal, so that could only be seen in the emotions that we extracted. And this was for a candidate, we call it hidden potential, so this concept that didn't start with a big excitement burst. So it had like bad market data, it started off slow. So if we look here at the data, you can see at emotions, this is the graph for the valence, so for the positivity. So it started with a rather low positivity, so below 0, which is not excitement. And it only throughout the 30 seconds of, so this is the timeline, throughout the 30 seconds of the clip, the positivity continuously increased, and thereby also the excitement. So the clip was kind of boring in the beginning, and when we then qualitatively checked this clip afterwards, it was really slow start, the hand was moving slowly, and there was nothing really interesting in there. But then, after 20 seconds, kind of.
15,
in
the middle of it.
In the middle, basically. So basically where we see here that it suddenly starts going through the roof, the valence, the positivity, was when a specific mechanic was introduced. So there was, in this video you saw then suddenly how you could, with a specific mechanic, improve your, I mean, we shouldn't reveal too much, but how you could level up, basically. And when the players saw this, they really got excited, and the valence increased. So that basically means that this one specific concept had a really strong mechanic. Just because of the conceptualization of the clip of this concept, it didn't get good market data and would not have been a good creative on the market.
And that's also the reason why I'm so happy that we did this, because normally before we'll be doing only the marketability, and then we'll be doing the surveys. And it was like second worst one. So again, ready to go to the basket and not talked about anymore. But then we saw the data, we saw the reactions, and there was something, like, to be very honest with you, like myself, I was really moved by the heat map, because you see there is a lot of activity and also excitement. So to me, it was like, okay, there's something. And also it was one of the few ones which had a really like nice uptrend in that. Yeah. And me, coming from finance, like when I see uptrend, I'm talking and asking questions. So it wasn't only me doing it, but with our aforementioned UX department, we did this, but it was just, okay, let's dig deeper. And the findings were quite quite nice to us, I would say.
Yeah. And basically, the takeaway from this was, okay, we have a really promising mechanic, just a not so compelling clip overall. But we'll get back to that later. The third finding that we had was basically the best concept. So there was a clear winner. It was one that had, as you can see here, very high excitement score in the beginning. So I don't know if you can read it in the back, but here it says excitement. And yeah, because it managed to induce the strong excitement burst in the first 10 seconds. And this clip also had the best market results, highest click-through rate, lowest CPM, and so on.
This is your high school quarterback, this clip. This is the one which everybody looks at, right? This is best in marketing, best in service, and it turned out but best in emotions too. But again, like looking at it, you might have already idea what we could do about it, right? Like, if you are reading in between the lines and if you are listening, you know that the chart where we were so excited about in a previous concept starts massively good, but then it actually loses a little bit of steam.
Yeah, so like, you see very high valence as a start, so significantly above 0. And then towards the end, as Gustav described, it loses its steam. And if you remember from the clip that we called hidden potential, there was a strong upwards trend when the new mechanic was introduced. So naturally, we thought, okay, it might be now a good idea to merge this overall winner, because it starts with really strong excitement, which causes good market data, with the hidden potential of the one that normally would have thrown into the basket. And that's basically the next step. So
that's the next step. And you would naturally expect us to show you results of that. We don't have them yet. I mean, again, as mentioned before, it's being done. But whenever we do something, we don't just throw it immediately and test it. We want to take our time to ask all the right questions. We want to prepare the test rightfully. But it's going to be tested very soon. And a couple of you might, if you reach out to us, might learn even what was the result of that. So, yeah, this was kind of not nice from us, I guess, to tease you off. And then...
But I mean, I'm really actually, so we really don't have the results yet. So the R&D team, as of now, is producing this new concept.
Hopefully,
so to say,
right?
If they're, and so stay tuned for this new concept. But what now is really interesting as well, and that's when I hand back to Gustav, is to see again this pyramid of the conceptualization and.
Because that is the real goal, right? We obviously like to have this shiny concept, which, again, the one I dubbed quarterback of the high school. And we also like to know what will be the next steps. But for me, mostly it is about the ways to kind of eliminate that conceptual error, which in the previous slide was this. And we believe that we managed to minimize it a little bit. This is not great mathematics behind this model. But the thing is that this is what we try to achieve, right? And we are absolutely sure there is no silver bullets. We are absolutely sure that we will making conceptual errors and that some of them will be overlooked. And some of the players wouldn't even like them. But we just want to minimize it because, again, like what is in the conceptual phase where it's a couple of thousands, maybe tens of thousands, could really become in production millions. And what it could eventually mean is that you will end up losing the concept because you will be focusing on wrong things and you will be like giving that one last shot, again, focusing probably on this red part. So winners could become very easily losers if that conceptual error is big enough. And that would be probably everything from my side, at least.
Yeah, from my side as well. We have one last slide, so feel free to reach out to Gustav if you want to learn more about mobile game development and concept phase stuff.
Yeah, stuff, exactly.
And reach out to me if you want to learn more about Brainamics. And now I think we have almost 30 minutes for questions and answers. So.
We don't.
Yeah, true, we don't have so much time.
How much do we have?
You guys have 15 minutes left if you want to
present
something more, what I see.
All right, thanks for your attention and
thank you very much.
Happy to answer any questions.
Thank you.
Okay, guys, so now is the time for a question round. So is there anyone at the audience who would like to ask a question? Okay, I see the first one.
Right. Very insightful presentation. Thank you very much. I love neuroscience. My question is because you said it mainly applies from your perspective, from your side of business to mobile games. How does it apply to video games, let's say AA or AAA?
So actually we work 50-50 with mobile games and non-mobile games. So it also applies to AAA games, PC console games. Essentially, any game that has a user experience, and that's every game, is applicable for this type of testing. So even if you have a hyper-casual game with a super simple core mechanic and no meta around it, you still want to make sure that it's fun game. So we work really with every game genre. So for example, with AAA games from CD Projekt Red or with hyper-casual games, like all of them.
Are there any tricks, like without this special neuroscience cap that you have on your head, are there any tricks that we can use without it?
Not yet, or at least not that I know of. So like one idea or one vision of Brainamics is that we collect a lot of data at the moment on how people perceive specific elements and features of games. What is their emotional reaction? Once we have a critical mass of this data, we can create playtest bots, which basically, so probably QA bots, that simulate thousands of gameplay scenarios to detect bugs in your game. And then what we can add as an additional layer is the emotion that would be perceived by a predefined target audience. So we basically take the QA bots and add as an additional layer the emotional reaction that we predict for a predefined target audience. So if you know your players, you can say, hey, we have this 30-year-old people who like to play tycoon and strategy games. And then based on our database, we can predict how they would react to a pre-simulated gameplay. And then you don't need the cap anymore. But this is still, this is 2 or 3 years in the future because the amount of data that is needed for that is insane. But yeah.
Thank you. Good presentation and very interesting stuff. I'm curious about the cost of doing this kind of play tests.
Gustav always gets the super discount.
Yeah.
No. So yeah, so we have 3 different packages. So there's it's a bit more complex, but on a very high level, there's usability playtests that we do. So if your game is not very fleshed out yet, very early stage, and there we have a €7,500 package. And then there's later on, once your game is already more advanced, the usability is on point, and we can really dig deep into what the players feel. There's a qualitative emotional test, which is also €7,500, and a quantitative test where we take a bigger audience, where we can make statistical conclusions for bigger populations. This is then €25,000.
All right, thank you. There was another person. Yeah.
I have a question regarding whether the participants, or rather, whether you have to prepare your model for the participants, or whether your data and your model is already generic enough to map the emotions to any participant. And I guess another question is how much time it takes.
Yeah, it's actually a good point. Forgot to mention that. So we do calibrate for each tester. So when you come in as a playtester, we first collect your baseline mood because it could be that you're very sad because your dog died or something like that. And then this really affects the emotions that we measure, obviously. So we collect your baseline emotional state, and everything that you experience during the playtest, we put in relation to your baseline emotion so that we can make sure that it's representative for the actual user experience. And this calibration is not long. It takes 2 minutes per player. And then what we also do is we fine-tune our models for each player individually. So most of the testers that we have, they are registered in our database, and we have 1 hour of training data from them already. And then once we extract their emotions, we use it on a fine-tuned model. So we take a deep learning model that is specifically trained for this individual based on the training data that we already have. So our models are generic to a certain extent, but we still do fine-tuning to ensure a high accuracy. Does it answer the question? Or yeah, okay.
Thank you for your presentation, super valuable stuff. There was an example of changing the mechanics in the game, and then the emotion graphic goes up. So how do you distinguish one aspect of game UX from another aspect? So for the graphics, I see it like you have eye tracking, but do you have something like that for audio, for the sound?
No, unfortunately not. No. So therefore, that's always the thing, what did now cause this specific emotional reaction, right? That eye tracking is helpful there because you already see where the attention is of the player. But for audio, there's, at least to my knowledge, no technique yet. And in general, the good thing about games is that you're really immersed into the game when you play it, right? So it's kind of clear that where the emotional reaction comes from. So it's most likely not the case that you think about, I don't know, your friend or whatever while you play the game, but you're really immersed into the game. So it should be clear that the game caused the emotional reaction. But for audio, I mean, maybe someone else has an idea.
Yeah, but also, like, we have seen it on average, right? Like, this was like 7 people reacted similarly in that particular moment. And if you really looked at the video, it was quite clear that there was a change in the scene. For better, obviously.
Yeah, I just wonder, does it ever make sense to separate one aspect of game UX from another when you're tracking emotions? Or it's like one entity, the whole UX of the game?
I'm not sure if I get the question correctly. By UX, you mean the UI or?
No. Like the whole game, which the player is immersed in. So does it ever make sense to distinguish like audio, graphics, and other stuff and measure them separately or not?
I mean, if something doesn't work well, you would be interested in the distinction. Actually, one of the games that we tested for you, there was this. Yeah, this was funny because you mentioned the audio. So I don't remember which game it was. Should I not?
No, you can say. Yeah, well, yeah. There was the audio of one of our games. I'm not going to name it because creator of music in that game could be in the room. The odds are small, but it could be the case. And yeah, we experienced the fact that the person was like people were extremely happy when they found out how to turn off music, which is, I guess, not the best feedback as artists you can get, but it happens, right? So, but at least we had some excitement there. Like there was people, like they were on the upper side of the...
Yeah. I think the game overall was good, like the emotional reaction was good. But then there was sometimes they were annoyed and there was like frustration. And once they managed to turn off, or once they found how to turn off the sound,
they were happy. Yeah. So
that happens, unfortunately. Thank you very much.
Welcome.
Thank you. Oh, I see another question.
I will expand on one of the previous questions. Is there any difference when mapping neurotypical and neurodivergent player while reading their reactions for the game?
Did you get it?
I didn't get it.
I also didn't. Can you say again?
If there is any difference when mapping neurotypical and neurodivergent people, the neurodivergent person, like someone with ADHD, autism, or something like that.
Neurodivergent persons.
Yes.
You mean? Okay. Yes. Yeah. Clearly. Like we don't know about our testers if they have ADHD or some other neuro disorder, and most of them are on some type of drug, right? And this strongly affects both valence and arousal. So sometimes we see extremely strange data, and we obviously don't use this data. And then when we ask the testers, they say, yeah, actually we are on Adderall because we have ADHD. But this completely messes up our models because the models are trained on people who are sober, so to say, and are not neurodivergent. So yeah, this completely messes up our models because they're simply not trained on this type. It's completely different brain data.
Okay, I see. Thank you for answering the question.
Okay, any other questions? Okay.
Hi. I want to ask, from your experience, is there any difference between like amounts of repetitions of some tests on the same tester? Like if you show for the first time a video or for 5th time, okay, like is the reactions on the 5th time are some different?
In other words, if the order of the videos you show in them...
No, if like the reactions are creating some tolerance in, you know? Like maybe the amount of happiness changes or some reactions are developing in the process of the tests. Yeah,
we didn't test for that. So I mean, your question is if one participant sees the same video 5 times in a row, and if he has exactly the same experience over and over again.
The difference between the first and the next.
Okay, so we didn't test that. We didn't test that. And I would not feel comfortable giving a prediction how it would be, but for sure it should be less, like weaker reactions, weaker emotional reactions, because you already know what to see, what you're going to see. But we didn't test for that, to be honest.
But it's interesting test, I would say.
Yeah, could be interesting. I mean, what I can say in general, like if you have, I mean, in any game you have a specific mechanic that repeats multiple times throughout the gameplay, and the first time, like a good game mechanic that is kind of timeless, there you see a very stable and steady development of the emotions. So like there's not a big change between the first and 10,000th time that you encounter this mechanic. However, there are some mechanics that kind of very quickly lose interest to do it, where you need some sort of upgrade, some sort of new spice to it. But when it comes to like pure video watching, where you don't have any interaction, I have actually no clue. We would have to test it.
Yeah, okay, thank you.
Okay. Are there any more questions? I cannot see any hands raising, so once again, big round of applause for our speakers. Thank you very much for the interesting session.
Thank you.